Alright, so it is time for our exam 2. So here is a review of what we've learned. First of all, understand you're going to have a matching section that has to do with all of your formulas. Those are the type of formulas you're going to need to know. Those are the formulas you have used. And I will give you the first quadrant of the unit circle so you can use that to however you want to do. On test 1, you had to fill in the unit circle, quadrant 1. But this time I'm going to give it to you because we are past testing over it. All right, so first question, and I've kind of spread them out so I don't have to rewrite everything. We are going to find the exact values of the 6 trig ratios when A is equal to 3 and B is equal to 7. So if A is equal to 3 and B is equal to 7, we have to find our value of C. We can use our Pythagorean Theorem because we've got to find all of those trig ratios. So we're going to use A squared plus B squared equals C squared. So we'll have 3 squared plus 7 squared is equal to C squared. So 9 plus 49 equals C squared. 9 plus 49 will get us 58 equal to C squared. Taking the square root of both sides, we get C is going to be equal to that square root of 58. It won't be plus or minus because it is a distance, and a distance can only be positive. All right, so now we're going to use our trig ratios. So the sine of theta is equal to the opposite over the hypotenuse. So here is our theta. Sine is going to be opposite, so 7 over our hypotenuse of the square root of 58. We need to rationalize that, so we're going to multiply by the square root of 58 over the square root of 58 and get 7 times the square root of 58 over 58. All right, so that's our sine value. So let's go find cosine. I'm going to alternate the colors just to make it a little bit easier to see all that writing. Okay, this will be the adjacent over the hypotenuse for cosine. So the adjacent will be 3 over the square root of 58. And we don't leave that. We're going to multiply again by the square root of 58 over the square root of 58. So we'll end up with 3 square roots of 58 over 58. All right, our tangent of theta is equal to the opposite over the adjacent. So that will be 7 opposite over adjacent, 7/3. All right, let's go do our cosecant. Cosecant theta is hypotenuse over the opposite because it is the reciprocal of that one. So the hypotenuse will be the square root of 58 divided by the opposite of 7. And then our reciprocal identity for cosecant, for cosine, too many in my head now, is going to be our secant theta, and secant theta would be equal to the hypotenuse over the adjacent. So the hypotenuse is the square root of 58, and the adjacent is 3. We have one more, and that'll be the cotangent. So cotangent theta is equal to adjacent over the opposite. So it'll be 3 over 7. So you need to be able to know those. You do not have to write all of those. I'm just helping you remember how to find those. So that's how you find those exact values of your 6 trig ratios. All right, now we're going to solve the right triangle using those trig ratios. And we've been given a few things. We've been told that angle B is 29 degrees and C is equal to 14. And of course we know that the right triangle is 90. So if we're looking to solve the triangle, remember there are 6 parts, 3 angles and 3 sides. So let's go find angle angle A. So angle A would be equal to 180 minus our 90-degree angle and our 29-degree angle. which will get us 61 degrees. So that's the easy part right there. And now we've been given our C, and so we need to find A and B. So let's go find A. To solve for A, let's do the cosine, because if we do the cosine of our angle of B, it would be equal to the adjacent over the hypotenuse. And I've told you before, try to use the things that were given rather than the things that you find, just to make sure you have less errors. All right, so we'll have the cosine of 29 would be equal to A over 14. We will multiply both sides by 14 and get that 14 times the cosine of 29, and you need to understand that's a degree, is equal to A. So if it is a degree, what mode does our calculator need to be in? It needs to be in degree mode. So if we put in 14 times the cosine of 29, we will end up with 12.2. So our A is equal to 12.2. All right, so we found our A. Now we need to find our B. So I'm going to still use angle B. Just in case I did a math error up here, the rest of it will still be okay. So I'm going to do the sine of 29 degrees would be equal to the opposite over our hypotenuse. And again, we'll multiply both sides by 14. So we end up with 14 times the sine of 29 degrees is equal to our B. And if we put that into our calculator, we will get that B is equal to 6.8. So you were given 3 parts, and you should find 3 parts. All right, so for the next part, we have to find the exact value for the trig function using the reference angle. So we've got to find the reference angle. So remember from your unit circle, if we're at 225 degrees, 225 degrees is going to land you in quadrant 3. Your closest x-axis is 180. So we've got to do 225 minus 180 will get us 45 degrees. And we need to understand what that means. So we know it's going to have the value of 45 degrees, but is it going to be the positive or the negative? Well, 45 degrees we know is a positive value, but 225 in quadrant 3, our sine values will be negative. So it'll be equal to the negative of our reference angle. The sine of 45 is the square root of 2 over 2, and we'll put the negative sign in there. I want to see all of these parts because you need to be able to make that connection with the reference angle and what's going on. All right, our next value that we need to find is our finding the exact value of an inverse trig function expressed in radians. So you can find this one by using your calculator, and you can also think about it through your unit circle. So if the cosine inverse, that means the value of it is going to equal negative 1/2, what is the angle? That's what you're looking for, is you're looking for the angle for that. So if you're using your calculator, you're going to have to be in radians, so don't forget to be able to change your mode to radians. And I can do this without doing that, but we'll see what we get here. So second cosine inverse of negative 1 divided by 2. And I need it to be exact value. So it's 2 pi over 3. So if you only get a decimal, that's not going to be good enough. Now, could I find that otherwise? Well, if I think about the cosine value, where does it equal negative 1/2? Well, in quadrant 2, we hit negative 1/2, and that's 2 pi over 3. Knowing our unit circle here, I know that the cosine of 1/2 is at pi over 3, so the cosine inverse would be 2 pi over 3. So that's where you can know it without using your calculator. And I would be able to do that way. But if you want to check yourself, you can use the calculator to do that. Now this one, find the approximate value of the inverse and express it in radians as well, round to 2 decimal places. This is not on our unit circle, but -1/2 was on our unit circle. So again, you're going to need to know your unit circle values if you didn't learn them for test 1. So I'm going to do the sine inverse of 3 divided by 8. And that will get me 0.384. Make sure you are I want it in radians in this case. So in that radians, it's going to be 0.38. All right, next problem. We have a 34-foot ladder. And our 34-foot ladder is leaning against a building. If the base of the ladder is 7 feet from the base of the building, so that's the first value we know is this will be 7. And we also know it's a 34-foot ladder. What is the angle of elevation of the ladder? So the big key here is you've got to know where your angle of elevation. It is the ladder where it elevates from the ground. So this is the theta you're looking for. And we also have to find out how high, so the height of how high the ladder hits on the building. So try to pick the easiest way to go about this. So if I need to find my theta, I have 2 values here. I have the adjacent and the hypotenuse. So I'm going to use cosine of theta is equal to 7 over 34. So my theta would be equal to the cosine inverse of 7 over 34. And so I'm looking, I need a degree. So I want my mode then to be in, second cosine inverse, 7 divided by 34. Because I'm looking for a degree, I need my mode to go back to degree. So pay attention on the test. Right? What mode are you in? So we need to be in degree mode so we get a degree out. And so theta would be equal to 78 degrees. And I'm going to put that down here. All right. Now, how high does the ladder reach? Well, we can assume that this is a right triangle, that the building was built level and it's got a right triangle. And because it's a right triangle, I can still use my a squared plus b squared equals c squared because I have 2 of my sides. So this would be, I'm looking for, let's call that my a. I'm looking for a squared plus 7 squared equals 34 squared. So a squared plus 49 equals 1,056. If I subtract the 49 over, I get a squared is equal to 1107. Taking the square root, it will be positive because it is a distance. So a would be equal to 33.3. Now, you can do it that way, or you could solve it another way. If I want to find this value, I know the degree here, so I could take the sine of this is equal to the opposite over the hypotenuse. So the sine of 78 degrees would be equal to h over 34. Multiplying both sides by 34, I get 34 times the sine of 78 degrees is equal to h. And putting that in the calculator using degree mode, h would be equal to 33.3. So either way you look at it, you're going to get the same value. You can do it this way or you can do it that way. As long as your angle is right, you'll be good to go. So we're looking at 33 feet. And you can go either way. Do you have to show your work? Absolutely. All right, now we have a tree, and a 97-foot tree casts a shadow that is 217 feet long. So our 217 feet is going to be at the bottom, because this is where my shadow for my tree is over here. And it's a 97-foot tree. So that's the height of the tree. Here's the length of the shadow. We want to find the angle of elevation of the sun. Again, it's where the sun goes up from the ground. So we're looking for this theta. So we have, with theta, we have the opposite and we have the hypotenuse. The opposite and the adjacent. This is our hypotenuse because we're again assuming that our tree is growing perpendicular to the ground. So we can do tangent theta. It would be the opposite over the adjacent. So theta would be equal to the tangent inverse of 97 over 217. And we want to be in degree mode because we want to get out a degree. And that will get us 24 degrees. So this will be 24 degrees. All right, next we're going to solve a triangle using the law of sines. So remember, if I tell you to do the law of sines, you have to use the law of sines. So our formula is sine of A over little a equals the sine of B over little b equals the sine of C over little c. I've got a triangle there. Now the triangle may not always reflect what the exact values look like. It's just a triangle on there, so you have some kind of drawing you can use. So don't get too like, well, that doesn't look, they look about the same, but 178, 132, it doesn't matter. You're just using it for a guide. So this one is 32 degrees, this one is 78 degrees, and we are told that little c is 12. Now remember, to do the law of sines, we have to have a pair. So we have an angle and a sine that both are the same letter, so we can use that. We're going to have to use sine c over little c. And we have the angle of A, but we don't have the angle of B. So perhaps the first thing we can find is our angle B, because all of our angles in a triangle add up to 180. So the angle of B would be equal to 180 minus our 78 plus our 32, and that gets us 70 degrees. So that's the first thing we can find. Now, let's go find, we have our A, so let's go find the sine. We're going to use angle C over little c is equal to the sine of A. Sorry, I got a frog in my throat. Over little a. We'll cross multiply and end up with A times sine of 78 degrees is equal to 12 times the sine of 32 degrees. We'll divide by the sine of 78. So A is equal to 12 times the sine of 32 degrees over the sine of 78 degrees. Now I will tell you it's best that you rewrite this so you can really see what you're doing and don't try to just jump steps. The more work you show, the more credit you can get. When you should be in degree mode because you're putting in degree angles, and you should get 6.5. So now that we have A and we have C, you cannot find B using the Pythagorean theorem because this is not a right triangle. You can only use the Pythagorean theorem for right triangles. So for this one, we're going to have to still use the law of sines. I'm sticking with my C values because those were given. So the sine of 78 degrees divided by 12 will be equal to the sine of 70 degrees, which is my B angle, over little b. Cross multiply and I get B times the sine of 78 is equal to 12 times the sine of 70. Divide by the sine of 78, and we'll end up with B equal to 12 times the sine of 70 over the sine of 78, which would be 11.5 when you put it in your calculator. All right, so law of sines means you have to use the law of sines. Next problem we're going to do is the law of cosine. So the law of cosine, remember, if you have a squared is equal to b squared plus c squared, we're doing a minus, not an equal sign, minus, it's going to be 2 times your b and c times the cosine of the a. So remember, it matches on the outside, and it's going to kind of match here on the inside. If you're doing b, it'll be b squared is equal to a squared plus c squared minus 2ac times the cosine of b. And c squared would be equal to b squared plus c squared, plus a squared. I was looking up above. We're doing c, and it is addition. Normally we would write it as a squared plus b squared, but it's addition, so it doesn't matter. And this is multiplication, so it also doesn't matter. So 2ab cosine of c. So the order in which you put those two values won't matter as long as you have the right values, because when you add them, it's the same, because it's not subtraction, and this is multiplication over here. So order won't matter. And remember, I also told you that you could solve for cosine of a, and that would be equal to your a squared minus your b squared minus the c squared, because you move them over, and then you would divide by the negative 2bc, and that the bc's here would match, and then you could solve any of the rest of them. So it would be cosine of b, then that would be b, this would be a, and this would be ac. So those can help you to know if you understand that part. Otherwise, do it the long way. It'll be fine. All right, so let's go see what we've got on our triangle. We are given that angle B is 83, little c is 4, and little a is 6. You can't use the law of sines, even if you wanted to, because you don't have a pair that go together. And because I tell you the law of cosines, you have to solve the whole thing using the law of cosine. You can't do part of it and then go do the law of sines. You will not get full credit. Law of cosines means that's what I want. All right, because I need to know that you know what's going on here. So we can solve, we need to solve for A, we need to solve for C, and we need to solve for little b. We can go with any part that we want to. Let's go up here and let's see, let's do little b. Using our formula, we'll have b squared is equal to our a squared, so that'll be 6 squared plus our c squared of 4 squared minus 2 times 6 times 4 times the cosine of 83 degrees, because that's our b. Now you can put this all into the calculator. You'll end up with b squared is equal to 46.15, and it continues on. Like I said before, you don't have to do all of that. Let me type this in real quick. So we'll have 6 squared plus 4 squared minus 2 times 6 times 4 cosine of 83. Made sure I was in degree mode. So I get this big long number. I now need to take the square root, so I can do second square root, second, and answer, because that'll put that big long number back in there, and then I can get my value. So it's basically 6.8. So that our b, because we're going to take square root of both sides, we'd get 6.8, and I've told you before, I'm okay if you take it to a whole number on these, because we're not doing like engineering right now, and it'll make it easier when you go find the other angle. So now that we have b, we need to find, let's go find angle A, and we're going to use our formula that I popped up here. So our cosine of A will be equal to A squared minus B squared, which we just found, minus our C squared, all over negative 2 times 7 times 4. This is where it's easier with the whole number than if we put in a decimal, but I'll take it either way that you figure it out. On these, remember, you're going to have to do the entire top divided by the entire bottom if you don't use a fraction in your calculator. So you should get that this is equal to 0.5178, dot, 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 dot. And again, you're going to use your second answer. So A would be equal to the cosine inverse of the 0.5178, dot, 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 dot. And it'll be equal to 58.8 degrees. And again, you can take it to a whole number. I'm okay with that, because everything that was given to you was a whole number. So using that second answer key can help you not have to type in so much. All right, so then angle C, all of our angles in a triangle equal 180. Whoops, I don't know why I keep writing equal signs. That should be a minus. And we're going to subtract out the angle we were given, angle B, and the angle we just found, angle A, and we'll end up with 38 degrees. So we should have 3 answers. We were given 3 parts. Find the other 3 parts to solve. All right, our next problem, we're looking at land in Rockwall, Texas. It's valued at $27 a square foot. I made up this problem, so I don't know that that's true. What is the value of the triangular lot with sides of lengths 83, 56, and 125? So there's 2 formulas we're going to have to know here. First, the area is equal to S times S minus A times S minus B times S minus C. Remember that the S is equal to all of your sides added together, which is your perimeter, divided by 2. So it's your semi-perimeter. So we're going to multiply the semi-perimeter times the semi-perimeter minus each of the side lengths. This is how we can solve a triangle that we only have the sides for. All right, so let's go find our S. So S will be equal to the 3 lengths of our sides right here, 83, 56, and 121, and then we'll divide it by 2. It totals out to be 260 divided by 2, which is 180. Oh, sorry, 130. 130, sorry about that. All right, now our area will be equal to the square root of 130 times 130 minus our 83 times 130 minus our 56 times 130 minus our 121. You can put that in the calculator and get that. A is equal to 217.24, and it continues, so 2 decimals will work. And then you're going to multiply that by 27 because it's $27. So you will get 54465.50. So that would be the value. So first we had to well, you've got to find that area in order to find the value of the lot. So that would be your final answer you're looking for. All right, so our next problem is a bearing problem. So the bearing problem, we are looking at solving by using heading and bearing information. We're going to round to the nearest mile if necessary. We have 2 airplanes leave an airport at the same time on different runways. One flies on a bearing of north 40 degrees west at 110 miles per hour, and the other airplane flies on a bearing of south 30 degrees west at 190 miles per hour. How far apart will the airplanes be after 1 hour? All righty. So we're going to draw a couple of things on, I've given you, I will give you something like this on the exam. So the first airplane is north, 40 degrees west. So north, and then we do 40 degrees, so that's about 90, so kind of about half of a 90. It's an estimation. If we mark it, we'll know. He's going 110 miles an hour. So we know that that's a distance of 110. The second airplane is south 30 degrees west, so we're going to go about 30 degrees this way. So this will be an angle of 30 degrees, and he's flying at 190 miles an hour. And so we need to find this angle here because we are looking for the distance between the two planes. So we need to know this angle. So we talked about this when we were studying these. If I have this perpendicular line right here, which just happens to be there in a nice easy spot for us, we know that all of this equals, it's like half of a circle, it's going to be 180 degrees. So with that, I can take 180, so I can find my angle. So the angle that I'm looking for is going to be 180, and I can subtract out the 40 and the 30, and that'll get us a 110 degree angle. So this angle is 110 degrees. Now I can use my law of cosines to solve for this side, because I have two sides and I have an angle, but none of them are, I can't use the law of sines because I don't have any that are matching. All right, so I'm just going to do the formula of a squared is equal to b squared plus c squared minus 2bc cosine of a, because we haven't labeled anything as far as sides in that. So I'm looking for this one. So my a squared will be equal to one of my sides, it doesn't matter which side you put first, plus the other side, minus 2 times those numbers, times the cosine of our 110 degrees. We'll put all of that into a calculator, and we get a squared is equal to 162496.44, and we'll take the square root of both sides. Again, you can do the second answer in your calculator. A would be equal to 249.99, and round to the nearest mile will be 250 miles. And that would be your answer. All right, next problem. We are going to find the amplitude, the period, and the horizontal shift of the function, and then graph one complete period. Label the increments on the graph for full credit. Extend the graph as needed. Alrighty, so first things first, amplitude. Remember, we're looking at y is equal to a times the sine of k times x minus b. So the amplitude is the a, it's the absolute value of it. So absolute value of 2 will be 2. Our period, because it's a sine curve, would be 2 pi over k. Our k is equal to 1, so 2 pi over 1, so it'll be 2 pi. The horizontal shift is going to be opposite of what you see, so it's not the negative but the positive of it, so it'll be pi over 2 to the right. All right, so I'm going to make some marks down here. I know that this will be 1 and this will be 2, -1 and -2. And then I'm going to do increments of 4 for a pi, because that'll make it easier for me to kind of see where I'm at. So 1, 2, 3, 4, this would be a pi. 1, 2, 3, 4, this would get me 2 pi. That can kind of help me a little bit. Now, that means that this is going to be pi over 2. And another part over would be 3 pi over 2. And another one over, this will be 5 pi over 2. You need to show me where you're landing here. So remember, to find those start and stop values, if we've got pi over 2, we've started with, we have to add the 2 pi, because that's our period, which would be equal to pi over 2 plus 4 pi over 2, which will get us 5 pi over 2. So that's our stopping point. And then we have pi over 2 plus our pi would get us pi over 2 plus 2 pi over 2 will get us 3 pi over 2. So that's the middle part. The first part's easy because we're adding 0 plus our phase shift of pi over 2 gets us pi over 2 to start with. All right, so on this, if I'm going from pi over 2 to 5 pi over 2, and I've marked these. Now, do I have to mark all of that? No. I counted over 4, so it made it easy for me because I'm doing a shift of pi over 2. You really need a pi over 2 and a 5 pi over 2, and then understand you need these marks here in order to graph it. But you have to show me the start and stop. I want to see that. You got to give me something. You can't just graph it. All right, so I know that my amplitude is at 2, and we are doing a sine curve that normally starts at 0, so it'll start here at our pi over 2. Let me use another color here. So we'll start at pi over 2, and then at this part, it'll hit at the 2. So it'll be right there. It'll be back to 0. It'll hit about right here, and then it'll be back to the 0 because that's the behavior of our sine graph. So it'll curve up and curve down, and it'll curve this way, and it'll curve back up. And that's how you're going to graph that. And that's how you can find the parts you're looking for. Again, I don't necessarily need to see these 3, but I have to see something. You can't just not tell me what some of the values are. Make sure you study.